Okay, let's start the next problem. See, it's a very important problem. In this problem, the slope is given. We'll see how to solve the problem when the slope is given. A pipe of 300-meter long has slope of 1 in 100 and taper from 1.2 meter diameter at the higher end and 0.6 meter diameter at the lower end. Quantity of water is flowing 5,400 liters per minute if the pressure at the high end is 68.67 kilopascal. Find the pressure at lower end, neglect losses. See, from this problem, you can see the given data are a length of the pipe is given, that is 300-meter long, and slope is given, that is 1 in 100. Then it is taper from larger diameter is 1.2, that is a D1, to D2 is 0.6 diameter at the lower end. Then quantity of water is flowing, that is 5,400 liters per minute. That is in terms of liters per minute. We need to convert that into meter cube per second. Then pressure at the higher end is 68.67 kilopascal. It is also in the form of pressure in terms of kilopascal. We need to convert that into Newton per meter square or Pascal. Therefore, you can observe the diagram. We'll observe the diagram. Here the slope is given, that is 1 by 100. So you can observe it from the diagram. See, if the slope is given, remember that Z1 can be calculated the slope multiplied by length. The slope multiplied by length always gives your, that is Z1, the height from the datum line to that section 1 height. That is Z1 is equal to slope is 1 by 100 multiplied by the length gives Z1 is equal to 3 meter. Then write down the given data, that is length of the pipe is 300 meter, then slope is 1 by 100, then diameter at the section 11 is 1.2 meter, then diameter of the section 22 is 0.6 meter. Flow rate Q is equal to 5,400 divided by 1000, then minutes to second, that is again divided by 60, that is 1000 divided by 1000 into 60, it comes 0.09 meter cube per second. Then pressure is given, that is pressure at the section 1 is 68.67 kilopascal, that is 68.67 into 10 raised to 3 Newton per meter square. Then they ask to find what is pressure at the lower end, neglecting the losses. Pressure at the lower end is P2. See, remember carefully, remember here only they ask to find what is pressure, then that is P2. Pressure head means P2 by rho g. Therefore, again we know that the Bernoulli's equation of Bernoulli's theorem, that is P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V1 square by 2g plus Z2. It means we are applying the Bernoulli's theorem at the section 1 and 2. Then in this formula, P1 is known value, V1 is unknown, Z1 is known, Z2 is known, then P2 we need to find, then V2 is also unknown, but the discharge is given. Then we know the D1 and D2 is also. Then by using the continuity equation, Q is equal to A1, V1 is equal to A2, V2, we can obtain the velocity V1 and V2. Therefore, by applying the continuity equation, we are going to get V1 as 0.07961 meter per second. Then V2 is 0.3184 meter per second. Substituting these values V1 and V2, P1 and Z1, Z2 in the Bernoulli's theorem equation, Bernoulli's theorem, we are going to get P2 is equal to 98.05 kilonewton per meter square. So you can write in terms of Newton per meter square also. Okay, we'll see the next problem. Water is flowing through a pipe of 300 mm and 200 mm respectively. The intensity of pressure at bottom end is 24.525 Newton per centimeter square and pressure at the upper end is 98.81 Newton per centimeter square. Determine the difference in diatom head if the flow rate is 40 liters per second. So carefully read the problem, then try to write down the given data and try to draw the sketch also. Then the diameter of the section D1 is 300 mm, then D2 is 200 mm, that is 0.3 meter D1, 0.2 is d2. Then pressure at the bottom, that is P2 is equal to 24.525 Newton per centimeter square. It's nothing but P2 is equal to 24.525 10 raised to 4 Newton per meter square. Then pressure at the top is P1 is equal to 98.81 Newton per centimeter square. This is nothing but 98.81 into 10 raised to 4 Newton per meter square. Then flow rate is given, that is 40 liters per second, that is 40 into 10 raised to minus 3 meter cube per second. Then to find is what is the difference in that diatom head, that is what is the difference in Z2 minus Z1 or Z1 minus Z2. Therefore we need to apply what is we need to apply Bernoulli's theorem in order to determine the diatom head. Because we know that Bernoulli's theorem as a section 1 and section 2, P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2. Here P1 is known value, P2 is known value. We need to find what is the difference in the diatom head, that is Z1 minus Z2. Then V1 and V2s are also unknown value, but the discharge is given. Then again from the continuity equation, we can find out the velocities at the section 1 and velocity at the section 2. That is Q is equal to A1 V1 is equal to Q is equal to A2 V2. Therefore, substituting the values of Q and A1, we are going to get V1 is equal to 0.5661. Then similarly, substituting the values of discharge and A2, we are going to get the velocity at the section 2 is 1.2738 meter per second. On substituting the values of V1 and V2 in the Bernoulli's theorem, we are going to get the difference in the diatom head Z1 minus Z2 as 15.06 meter. In the next problem, see, this is also a very important problem. See, here the problem is a pump has a taper pipe running full of water. The pipe is placed vertically. See, here also pipe is placed vertically. If the pipe is placed vertically, the Z1 is always 0. The Z1 becomes a diatom line. With the diameter of the base and top being 1.2 and zero point 0.6 meter. The base diameter is 1.6 and the top diameter is 0.6 meter respectively. Pressure at the upper end. The pressure at the upper end means at the section 2 is 240 mm of Hg of vacuum pressure, while pressure at the lower end is 15 kilonewton per meter square. Assume the head loss to be 20% of the difference of velocity head. Calculate the discharge of flow and difference in elevation is 3.9 meter. See, carefully read the problem, try to understand. See, this is also very important problem. See, there is a taper pipe full of water. Pipe is placed vertically. Then the diameter of the base diameter is d1. D1 is 1.2 meter. D2 is 0.6 meter. Then pressure at the upper end is P2 is 240 mm of Hg of vacuum pressure. Since the pressure vacuum pressure means it is always negative pressure, it is 240 mm of Hg. Here we need to convert the pressure in terms of it is in the form of head 240 mm, then we need to convert that in terms of Newton per meter square. Then lower end is 15 kilonewton per meter square. Then the head loss is given here. Here the head loss, remember, if any loss is given, we need to substitute. See, this is at the section end. At the end of that Z2, we need to add these losses. See, because at the end we can measure the losses. Therefore, at the end, at the end means the section 2. At the section 2 says that is P2 by rho g plus V2 square by 2g plus Z2. Then we need to add the head loss here, or any losses is given. That is 20% of velocity head. Then here we need to convert that pressure 240 mm of Hg of vacuum pressure. See, the conversion is P by rho g. P by rho g is what pressure head is given. The pressure head is P by rho g is equal to 0.24 of meter of vacuum pressure. Therefore, since it is a vacuum pressure, we need to write it as a minus 0.24 meter. Then in order to find out the pressure, we need to multiply by density and gravity. Here the density is Hg, that is rho Hg into G into 0.24. It gives P2 is equal to minus 32.01 kilonewton per meter square. So if you want to maintain in terms of kilonewton per meter square, you can make it as kilonewton. Otherwise, you can convert that into kilonewton per meter square or newton per meter square. Then with this, then we need to find what is discharge. Q is equal to what? Then Z1 minus Z2 is given as 3.9. Then the very important factor head loss is given. The head loss is equal to 20% of velocity head. Differential velocity head. The differential velocity head means that is v1 square by 2g minus v2 square by 2g is nothing but differential velocity head. Therefore, head loss HL is equal to 20% 0.02 times of differential velocity head, that is v1 square by 2g minus v2 square by 2g. See, this HL we need to add at the section 2 after the Z2 value. See, we can see in this equation, the Bernoulli's equation, that is at the section 1 and section 2, P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2. See, here we need to consider the losses, that is HL is equal to, and substitute all the values in this equation. P1 by rho g is known value, V1 square by 2g is unknown, then Z1 is Z1 minus Z2 is given. Then P2 by rho g is also known value. Then V2 square by 2g is unknown value. Then HL is equal to 0.02 times of V2 square by 2g minus V1 square by 2g. See, in this equation, V1 and V2s are both unknown values. See, this above equation can be solved by writing the similar terms one side. That is in terms of P1 minus P2 divided by rho g is equal to V2 square by 2g minus V1 square by 2g plus Z2 minus Z1 plus 0.2 times of V2 square by 2g minus V1 square by 2g. Therefore, after writing the similar terms one side, we are going to get P1 minus P2 divided by rho g is equal to 4.793. See, here the head loss is 0.2. See, but here we written 0.020%, that is 0.2. So take it, there is a mistake in that. First head loss is equal to, in the first given data, that is not 0.02, that is 0.2. See, we corrected in the Bernoulli's equation substitution. Therefore, 4.793 is equal to Z1 minus Z2 is 3.9 plus 1.2 into velocity head, that is V2 square by 2g minus V1 square by 2g. Therefore, above equation further simplifying, we are going to get V2 square minus V1 square is equal to 1.459 meter per second. So you can call it as equation 1. Then with the help of continuity equation, we can find out the velocity V1 and V2. See, that is Q is equal to A1, V1 is equal to A2, V2. Therefore, substituting the values of A1 and A2, then here we can find out the velocity V1 in terms of V2 or V2 in terms of V1. Here I'm going to find out the values V1 in terms of V2. Therefore, V1 is equal to A2 V2 divided by A1. On substituting the values, we are going to get V1 is equal to 0.25 into V2. See, substituting this value V1 in terms of V2 in equation 1, we get V2 as 1.247 meter per second. See, since V1 is equal to 0.25 times of V2, see, we already find out the value of V2 is equal to 1.247. Therefore, V1 is equal to 0.311 meter per second. Since the question is asked to find out the discharge, we can find out Q is equal to A1 by A1 into V1 or A2 into V2. You can use anyone. Therefore, I'm substituting the Q is equal to A1 V1. We are going to get Q as 0.3525 meter cube per second. Thank you.